All right, this is our tutorial for question 2 of our daily review. A reminder that we're not going to go over any specific problems that are on your daily review. However, this will walk you through the process of how to solve any question 2 or any week's work for question number 2. They are always the same types of questions. In this case, we are always working with division for question 2, and we're going to be working with long division. I think it's helpful when we work on division to understand some key vocabulary words. So I'm going to spend a few minutes going through some vocabulary, and then I will walk you through a tutorial about how to do long division. If all you need is the tutorial, you can always check the timestamp in the description of the video, and you can skip ahead to that tutorial part. But first, let's go ahead and walk through some quick important vocabulary terms about division. So when we talk about division, we are talking about splitting something up. And in math, we're talking about splitting things into equal parts or equal groups or equal portions. And so we're always going to be thinking about that equal part is really important when we talk about division in math. Now, in a division problem, there are 3 really important parts. The first part is what's called the dividend, and that is the thing or the number that is being split up. It's what is being split up into groups or into equal parts. Then, if we've got something that's being split up, we also have the divisor, which is how many equal parts it's being split into. And that leads us to the quotient, which is the answer to our division problems, which also tells us how much is in each one of those equal groups. Now, here's a very quick example of that, and I've color-coded this example to help us match those vocabulary terms with the parts of this problem. And it's a simple example that uses mental math instead of complicated long division, but that helps us gain an understanding of what our steps are and our process is for long division here in just a moment. So we might have something like 12 cookies and 3 people. So we might want to figure out, well, how many cookies would each person get if I were to split those cookies up equally between everybody? Now, again, that's mental math. We would hopefully know that, or we could figure it out. We could kind of count with our fingers and figure it out that each person would end up with 4 cookies. But helping us have an understanding of what is the dividend or the thing that's being split up, what is the divisor or that's the groups, and what is the quotient or that's how much is in each inside of each one of those groups can help us with some of our bigger problems that we have. So let's go ahead and take a look at our 5 steps for division. We've got 5 steps for division: divide, multiply, subtract, bring down, and repeat. And we're going to walk through these 5 steps here very quickly. We are going to walk through these steps as many times as we have to until that subtract step that is there, until we see that subtract step give us an answer of 0. Until we get an answer of 0, or sometimes when we're working with complicated problems, we get a repeated pattern that will happen. And that means that problem, that division problem, actually will never end. If we see a repeated pattern happening, we can also stop at that point in time. So let's go ahead and look at an example. In this case, we have 1,365 being divided by 8. Now, we talked in the first part of this video about what the different parts of a division problem are, and we talked about that because sometimes setting up long division problems can be the hardest part of long division. We have to remember what part goes inside of our division box and what side goes what part goes on the outside. And the dividend, or the number that's being split up, is always what goes inside of that box. So 1,365 is what's going to go inside of that box, and 8 goes outside. Now, when we work with numbers like this, in this case we have one really big number and a smaller number, it's generally pretty obvious for us how we're going to split those things up. Usually we're going to take that bigger number, and we could think about it, the example we talked about, cookies and people, 1,365 cookies being split up by 8 people. That makes a lot of sense, and I'll tell you, I certainly want to be a person in this problem, because that sounds like I'm going to get a lot of cookies. But that sounds like it makes sense. It seems pretty logical. However, one of the things we have to be aware of is we have to be careful, because especially as we continue to advance in math, it's not always just the biggest number that's being split up into the smallest number. That's not always how it works. Now, in this example, that's what we're doing. But sometimes you can have examples where that it's different than that, right? You might have an example where you said, well, there were 1,365 people, and they each walked a total of 8 miles. How much did each person walk, right? So now we have that smaller number that's being split up by that bigger number. So that does happen occasionally. So that's where I go back to some of those vocabulary words. Okay, but that's not what this problem is about. We're just focused on our long division. So we've got 1,365 being divided by 8. So let's go ahead and start walking through those 5 steps. Our first step is to divide. So I'm going to take 8 and I'm going to divide it into that first number. I'm trying to ask how many times can 8 fit into that first number, which is 1, without going over? Well, hopefully I would notice that it's going to give me 0 there. So if I walk through those steps, I would go 8 can never fit into 1. That's a 0. Then I multiply. 8 times 0 equals 0. And then I subtract. 1 times 0 equals 1. And then I bring down, and I end up with 13. And now I start to repeat that process. But one of the things that actually happens a lot when we're working with long division is sometimes that first or even second number might not be divided. And what you're going to notice there is where we actually can take a little bit of a shortcut. Instead of writing all of that down, I can simply start to think about, well, it's going to end up being 13 there. So instead of writing all those steps down, I'm just going to start there. So again, I'm repeating at this point. 8 goes into 13. It can fit in 1 time without going over. Now, if you have problems or struggles with your mental math facts, grab a multiplication chart, and you can look at the number 8, and you can use your finger and walk across until you see a number that's bigger than 13. In this case, it would be 8 and then 16. And so I would know, well, it can't fit in 2 times. It can only fit in 1 time. So you can use a multiplication chart to help you out. Now my next step was to multiply. 8 times 1 would give me 8. Then I subtract. 13 minus 8 equals 5. And then I need to bring down my next number. So I'm looking in my problem. I've already dealt with the 1 and the 3. Now I'm bringing down the next number, which is a 6. I'm going to end up with 56 there. So now I repeat that process. I'm now going to take a look at 8 and see how many times it goes into 56. I should already know that it can't go into 5 because that was what's left over. So I'm looking at 56. 8 goes into 56. Again, if you need to use a multiplication chart, you can put your finger on 56, put your finger on 8, walk across until you see a number that is bigger than 56, and see how many times you can fit in without going over. Okay, in this case, I'm dividing. I know that that's 7. If I multiply, that gets me 56. And that would get me 0. Now, we said when we subtract, we want to get to 0, but I still have a number that I haven't dealt with yet. So I need to bring down that 5, and I can start to repeat that process again. In this case, 8 cannot ever go into 5. And so what you probably did in the past is you might have written something like, the answer to this problem is 170 remainder 5. However, in 6th grade, we no longer use remainders. Okay, and so we're going to work with 2 different options that you can continue from here. One option is going to be with a decimal, and one option is going to be with a fraction. So we don't ever want to use those remainders anymore. We're going to work with our decimals first, but what I actually want to do is I want to just remember where we kind of left off. So where we left off was at this point, we ended up with 0 and 5 left over. And that's going to be what we use when we get to the fraction part. So I'm going to come back to that in a little bit. I've got the arrows that are sticking next to that point to help remind me. But let's go ahead and do the decimals. And you can see that I've already added a decimal after my answer because I know that I can add a decimal. And as long as that decimal is 0, I have not changed the number, right? 1,365 is exactly the same as 1,365.0. And in fact, I can add as many zeros as I want to in this problem, right? So here I just added a bunch of zeros because I don't know how many of them I'm going to need. And now I can continue to repeat this process. And we already knew that 8 couldn't go into 5, so I can go ahead and bring down my next number, which would be a 0. And so now I can walk through, can 8 go into 50 without going over? In this case, it certainly can. 8 can go into 50. I'm just going to extend that division sign. It can go in 6 times. When I multiply 8 times 6, that gives me 48 as an answer. I subtract. In this case, 50 minus 48 equals 2. I'm not done yet. I didn't get a 0. I don't have a number that's repeating yet, so I continue. I bring down my next 0. 8 can go into 20 2 times. 8 times 2 is equal to 16. I subtract. That gets me to 4. I don't have a 0. I don't have a repeated number, so I continue. I bring down my next 0. In this case, 8 can go into 40 5 times. And now when I do my math, when I multiply and I subtract, I end up with 0, so I know that I'm finished. And all I need to do now is make sure that I include a decimal in my answer. And so this also is a little practice from problem number 1. We just make sure that decimal goes directly above what was underneath it there. Okay, so my decimal is directly above the decimal in the original problem that I added. And so my answer to this problem is 170.625. So I can go ahead and write that down. Now, we said there were 2 possible ways you could do this. One is using decimals. That involves continuing to practice those steps for long division, which is awesome. The other way is using fractions. And remember, I put some arrows next to where we left off. So I'm going to go back to that step. That was where we left off when we kind of got to the end of this problem, when we got stuck. And so if I ever end up there, I can continue. I can put a decimal and as many zeros as I need to, and I will get my answer as a decimal. And the other option is to write my answer as a fraction. In this case, when I end up with 5 as my answer when I've brought things down, now I can simply write my answer as 170 5/8 because I have 5 left over that are being split up into 8 parts. And in fact, if you were to grab a calculator and you were to divide 5 divided by 8, you're going to see that that decimal number that you end up with is 0.625, which is where that value comes from. So those are the steps to do long division. Obviously, there's lots of other resources where you can continue to practice long division throughout the course of this year, but this is a great one for you to go ahead and take a look at.